Well, good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this workshop brought to you by CloudBees. My name is Cody, and welcome back to Techstrong Learning. So, just to dive into our workshop, our title is Enabling Your Dev Team with High Availability and Scalability. And joining me today is Ian Kurtz, Sales Engineer at CloudBees. We're also joined by Erica Abernathy from CloudBees, who will be kind of filling in for Bill Garrett, Principal Solution Architect at CloudBees. Bill is also here, but he's a little under the weather, so I think we all win having an extra brain on the board here today with us. So with that, Ian, Bill, and Erica, thank you all so much for joining us. Ian, do you want to dive us straight into things?
Absolutely. So today we are going to be, focusing on high availability and horizontal scaling within CloudBees CI. If you're not familiar with CloudBees CI, we'll kind of drill into that towards the beginning of the workshop. Won't spend too much time on it, but we also want to give some developers, some love today. So we'll be covering some concepts with regards to how this type of architecture can still enable developers to be productive. So we'll be covering other concepts like workspace caching to improve, end-to-end build times within your CI pipelines. And on top of that, you'll be introduced to a brand new logging experience that I'm sure many of you will love to see. 2 words, console output. And I've probably triggered the majority of the attendees today just with those 2 words. So we have an alternative solution to the console output that we'd love to show you. And that's towards the end of today's workshop. What we'll be doing towards the beginning is covering what you will first need to get sort of set up in our platform to run the labs that we'll be executing today. And again, those are going to be specific to our new high availability and horizontal scaling capabilities. Before we get hands-on, we'll cover the solution architecture, some of the requirements that you would need as a CloudBees customer to get set up with that type of architecture. There's a lot of really cool benefits that we'll look to cover today. The CloudBees Pipeline Explorer, actually, we'll flip those around because we want to cover workspace caching. So, as a result of the first few labs, you'll be comfortable, with how to configure high availability, with what the architecture is doing kind of in the background. And then at that point, well, we'll want to get a pipeline, onto that controller or one of our controllers. And then from there, how as a developer, can I troubleshoot any errors associated with that pipeline in an efficient manner? How can I visualize that? How can I contextualize the results of a given pipeline? And all of that will be done through that new logging experience that I had mentioned with the CloudBees Pipeline Explorer. But again, the star of the show is really how we can sustain your growth in terms of CI/CD workloads through our high availability and horizontal scaling mode. Cody had mentioned that there are a couple of links in the handout section that you'll want in order to actually be hands-on with me today. We've got a lot of different people across the globe. That is awesome to see. Saw some people from Honduras, Botswana, and even Germany. So I appreciate everyone's attendance today. So a couple of things to cover. You will need internet access, surprise. And access to github.com. I'll explain why here once we dig into the first lab. Basic understanding of how Kubernetes works. If you don't, we'll cover some fundamental concepts. But at the minimum, I think you would want to understand, what a pod is and, how that might differ from a Docker container. Obviously, a basic understanding of Jenkins pipelines, CloudBees CI being the enterprise offering of Jenkins, which we'll cover here momentarily. And then we do recommend the usage of Google Chrome just for the best browsing experience. I highly doubt that anyone's working off of their phone right now, but if you are, and you're just kind of tagging along for the ride, then go ahead and use that QR code if you'd like to enroll. And that'll take you to Heropa, which is the platform that we're actually using for the workshop today. A little bit of a twist in regards to how we've usually run that. The lab content that you'll want to use to actually follow along is going to be hosted on actually my GitHub page that I created for today. So you'll also find that in the handout section. So the link right above the lab content that you see on the slide is what you'll actually need to get enrolled in Heropa. If you're not a user, you'll want to register. So that'll take you to the registration screen where you'll provide your first name, your last name, your email address. You'll create a password, and then from there, you're in. So you've officially enrolled in the lab for today. So under that My Labs view, you should see either the View or View Workspace button within that workshop you just enrolled in. And then from there, you should be redirected to your workspace. I want to say that we've got about 50 to 60 seats sort of scoped out for today's workshop. So it is a little bit of a kind of first come, first serve basis. We will leave these environments up towards the end of the day. So, if you don't get through all of the lab content, I'm confident we will. Or if you would like to do the labs in more of a self-paced format, that's also an option that you have, thanks to the links that we've provided. Another important thing here, we can drop this into the chat. The username for everyone is going to be the same thing as you can see on the screen. And the password is also going to be the same as the username. Very good security practices. So when you do log in to your VM, and I'll show you what that looks like here momentarily, you'll want to use those credentials, and then that will take you to where you need to be. So as you all do that, and again, if you do have and are experiencing issues, please post that within the Q&A section of this platform. And then either myself, Erica, or Bill will go ahead and help you out with any issues you might experience. If you do run into any issues accessing Heropa, the lab content, and we can't help you out in a timely manner, don't stress out. Just make sure you follow along with what we're doing. Again, this can be completed at a later time today in a self-paced manner. So I think we've covered our housekeeping items. And so as some of our attendees begin to register and access their workspaces for the workshop, I'd first like to back up. Let's zoom out and take kind of a 30,000-foot aerial view into CloudBees. So we started back in 2010, and our bread and butter was serving the Jenkins community. Kazuki Kawaguchi, many of you are familiar with as the creator of Jenkins, a legend in the industry. And he was our CTO for a while. So he really helped pave out what an enterprise solution for Jenkins would look like. And that's actually what we're going to be experimenting with today, CloudBees CI. So everything you implement in open source, including your pipelines, configuration as code, your permission scheme, all of that can be seamlessly migrated to our platform. And then you can begin as an enterprise organization to take advantage of more governance, additional scale with our modern architecture on Kubernetes. That significantly reduces overhead with respect to a lot of different operations from a configuration management standpoint. So the cluster that we'll be working in today is hosted in AWS, and it's running on EKS. So that's what we would call our modern architecture. You can still run CloudBees CI, traditionally speaking. Any infrastructure you have today, you can install our software on. Beyond that, so that's what we're going to be, that's the, again, our bread and butter. The past several years have been pivotal for CloudBees in terms of kind of transforming our offerings. And we now employ, enterprise release automation and deployment capabilities, feature flagging, compliance, and towards the end, we will, discuss the brand new CloudBees platform that we actually just released in November. But today, just know that we will be strictly dealing with CloudBees CI, which is why I imagine everyone is here. And the first order of operation is to really get an understanding of our new high availability and horizontal scaling feature. Traditionally, in open source Jenkins and in past iterations of CloudBees CI, you could implement high availability. It would require you to provision, new VMs, EC2 instances, storage in a much more manual effort, and that creates duplicate infrastructure. So as we dive into that, what we know is, well, overloaded controllers tend to be a problem. And that happens, due to a variety of different reasons. But when teams tend to work on, a single instance together, they're stepping on each other's toes. That might result in hundreds or thousands of pipelines. And, as a shared services administrator, I'm having to constantly band-aid that instance or increase the CPU and disk threshold. So you're constantly having these performance constraints for with these overloaded controllers, and it becomes even more of an effort to horizontally scale that out so that you can actually optimize the performance efficiency across your cluster. So this impacts every single person who utilizes something like CloudBees CI, whether you're a developer or a toolchain administrator. So high availability is a table stake requirement, especially for business critical systems like Jenkins or CloudBees CI. So an architecture where we give you kind of a single logical controller that can spread its workload across multiple replicas is exactly what we have released. And so that gives you the ability to horizontally scale without many human touch points. And that will maximize your uptime, right? So the Hazelcast library is kind of near and dear to this architecture. It's what we use to, kind of keep the state of each controller synchronized with each replica. But, a general idea or really a general understanding for the use cases is what we wanted to express here. So you would be a great target audience for this if you do have that type of monolithic controller I was just mentioning. If downtime is a problem for you, we realize that system upgrades may not be documented properly, or maybe stopping your delivery cycle. If this is just a part of a system requirement, again, it's much easier to set this up with CloudBees CI than it is in open source. So as we dig into that, let's cover really the traditional architecture, right? The classic controller is that single instance, right? With pretty much sole write access to the file system. So in that active standby or that active passive type of failover, there's no symmetric cluster, right? Where controllers are sharing workloads together. That's extremely hard to achieve. And so at any given point in this, classic type of architecture, only one of the replicas will actually work as the controller. So if and when a failover does occur, one of those replicas takes over the controller role, but you as a developer will experience downtime. Now, with CloudBees CI, the new architecture in active-active, we solve that challenge directly, right? So we do create, again, that single logical controller, thanks to a shared volume whether that's an NFS volume for on-premise installations or maybe EFS for AWS installations. These controller instances work simultaneously by splitting the load, of however many pipelines are running across the number of configured replicas, which is another thing we'll cover. So there's no concept of primary and secondary where there was with active passive. And this is available for both traditional and modern architectures. So the setup differs a little bit, but today we'll kind of be focused on what that looks like in Kubernetes. And this is a quick visual here. If we had a pipeline on controller one, kind of a little visual showing you what the load distribution would look like. So as jobs are queued and start to run on replica one, for example, or across the cluster, the load balancer, still a centerpiece to this architecture, will distribute them, to the various members of the replica set within Kubernetes. So it's all extremely transparent to you as the developer, or whatever your role is, SRE. It doesn't matter which replica a request actually lands on. All of the jobs are visible to you as an engineer. So it's very, very seamless browsing experience. And if one of those controllers goes down, say replica 2 in this example, you know that build number 3 will be distributed by the load balancer onto another replica. So that's randomly distributed and will give you a lot more business continuity, which is a centerpiece to one of our labs today. And then as that replica goes down, thanks to Kubernetes, a new replica set will be spinning up automatically, right? So that is another kind of crucial difference between the traditional architecture and modern, is that Kubernetes enables you with the ability to take advantage of horizontal pod auto-scaling, whereas traditionally you'd have to set a lot of that up on your own. So what we'll do is actually navigate into the labs now. And if you're in Heropa, what you should be seeing are a few different screens. When you open up the Google Chrome browser within your VM, you'll see the lab introduction page, and you can navigate to Operations Center using this link. So we can go ahead and open that up. I'm going to open that up into a different window, and then we can use those credentials that I shared within the chat, and we'll use those to log into CloudBees CI. So it's going to be system admin for both username and password, and go ahead and sign in. Doesn't like our password, so we'll just click past that warning. And here we are, right? So Operations Center is a place for us as, again, maybe an SRE or a shared services engineer, to get an understanding of, how many controllers do I have within my cluster? In an enterprise or a real world scenario, I might have 50 or over 100 controllers here. All of that is visible through what we call Operations Center. So it kind of sits above all of your instances and can give you, the ability to centralize operations like the configuration of RBAC. You can centralize system upgrades. It's very powerful, and again, something you don't have in open source. What we'll also take note of immediately is that we have 2 controllers. They're both online, and under the pod status, you'll see that we have 3 out of 3 replicas for controller 1 and 2 out of 2 replicas for controller 2. Now for the high availability labs, we'll be focusing on controller 2. And that's exactly where we're going to start here. What we want to do with this first exercise is verify that, first and foremost, our controller actually does run in high availability mode. We'll actually switch to another replica, get an understanding of how that works. We'll enable what we call developer mode, which again will give you kind of that seamless browsing experience to understand which replica you're running on, and some other UI UX benefits. And then we'll kind of review the high availability information displayed by a certain replica when running in developer mode. Easy peasy, nothing too crazy that we're doing within this first lab. And by the way, we did have some syntax errors associated with some of these images. So these same instructions, if you just clicked on view on GitHub, you can open that up into a different tab. You can view these exact same instructions in GitHub. That's kind of why I had mentioned that it would be nice to have access to GitHub as a prerequisite. And those images are rendering properly there. So what we want to do first is verify that we have two replicas, which we've already done, right? So they exist. If we actually wanted to go and take a look at the configuration for this specific controller, we know that, all right, it has a persistent volume claim, and it has a dedicated storage class that we actually need to run this in high availability mode. So that is a requirement for this type of architecture, is you need to be able to have read, write, many access to that shared volume. In this case, it's going to be NFS, and we're probably using an EFS volume in the background in AWS. So our pod is started, it's running. We have 2 out of 2 replicas available, which is exactly what we want to see. And we'll click this wrench icon, the configure button for controller 2. And we'll actually see the high availability configuration. If you just do a control find on that, you'll see, okay, well, here's the Docker image that we actually want to use for this controller. If we were spinning up a new environment, you could select that before doing so. And all right, here's how many replicas we want by default. So if it's more than one, the controller will benefit from the type of horizontal scaling that I had shown within the solution architecture. And then we can also give this environment a maximum number of replicas. This is important, right? If our CPU threshold for this particular controller breaches 80%, we're going to want to create, another pod. So we'll take advantage of the horizontal pod auto scaling. And if the node itself that all of these controllers are running on breaches its CPU limit, thanks to, again, to the cluster auto scaling capabilities of Kubernetes in that fully managed type of architecture, it will create a brand new node, an EC2 instance in the example of AWS, so that you can begin to run your pipelines and you're not disrupting your business. And of course, the storage class. So we won't be diving into configuration as code today, but that is also a very, very powerful feature. I could wrap this entire configuration into a bundle and then replicate that or distribute that as I'm onboarding new teams who also have a high availability requirement. So I just wanted to show everyone what this looks like. We'll go back to the root level of Operations Center here. And then let's actually navigate into controller 2. So we have 2 folders here. And getting back to the labs, we want to actually view the configuration within controller 2. So what does that give us, and how many replicas do we have? We should see 2. And we can get there. Since we're not running in developer mode, we don't really know which replica we're on yet. So we can go and find that out, since we do have admin access, through the Manage Jenkins page. And then we'll scroll down and access CloudBees CI high availability screen. right off the bat, you can see which replica you're currently running on. But as a developer, you shouldn't have to go to this page, and you probably shouldn't even have access to this page, which is exactly why we have what we call this developer mode, which we will enable. But first and foremost, we see our controller is suffixed with a unique identifier for the current replica. And then we also get another replica that we can see here. Getting back to the lab, what we'll want to do is actually switch to another replica. So if your user session hasn't changed, replica isn't just going to switch on you, right? But if I'm a new login, right, I might be directed to the second replica. So we'll want to actually reset the sticky session so that we can see the change. The load balancer actually direct us to the other replica within this cluster. You know what? Let me rearrange my windows real fast. There we are. Okay, so we can reset our sticky session, and within a few seconds, we should see the flip into the other replica. That is suffixed with QKJR7, and sure enough, we were, right? In a real world scenario, you know, I didn't change my user session. I wouldn't reset my cookies, you know, randomly, where it would log me out of every site. But as a new user, I'm experiencing no disruption from a browsing perspective. I can easily switch between each replica. And then as we'll see, you know, in one of these upcoming labs, the state of each replica is in sync thanks to the Hazelcast Java library, which is lightning fast. And I see Joel had a question. You don't have an option for memory threshold. That's a good question. I don't believe that is an option for the high availability configuration. However, in Kubernetes, when you are deploying your resources, you should be able to specify your CPU limits and requests as well as memory. So that might be more of a Kubernetes-based operation than it would be for high availability in this case. That's a good question. Just keeping up with the Q&A here. How is the replica's Docker image preloaded? So if we, and I imagine that was on the configuration screen we saw. So it's preloaded because Operations Center itself was deployed using Helm. So there's a section, if I just go back to Operations Center, I can show you very quickly. If we go to configure controller provisioning, you'll actually see the Docker image that we passed using Helm right down here. So here's a previous version of the image, and we can delete that if we wanted to. And here's the current container image that we're using for these controllers, to answer your question, Hari. All right, so we'll get out of this screen. And now what we want to do, since we've switched to another replica, we want to go ahead and actually enable developer mode, since we'll be using that to seamlessly navigate to different replicas and get an understanding of which instance we're currently running on here. And that is literally the flip of a button. So what we'll do is apply, and then save that here. And you know what? I want to go back to this screen. So we'll reset the sticky session just so that we are we get transitioned back to the original replica, and then we'll actually review the information displayed on a running build, because there's also some uniqueness to that and how pipelines run on replicas, or at least how they're displayed. So we'll go back. We now know that we're in developer mode because we have this message that's being displayed in the footer. All right, well, here's the current replica we're on. And we know that's the kind of the secondary replica. So we want to switch, reset our sticky session again so that we can get switched back to our primary. And sure enough, we are. And we'll go back to the root level of this controller, controller 2, which you can navigate to through the breadcrumbs up here. And let's navigate into the team CD folder. We'll click into this pipeline titled job. I know, very advanced. And it doesn't have any builds. And you'll also notice that, hey, we're running on our original replica. It's exactly where we want to be right now. And I wanted to bring that up because as we run this pipeline, we'll see the name of the replica that has been attached to it, right? So this gives you some context. If you have a lot of pipelines, concurrent builds on a day-to-day basis, you get an idea of where those are running in the console or in the build history for a specific pipeline. We'll dive a little bit more into that as far as what the build history would look like if I had pipelines executing at the same time on different replicas. That is identified here within the build history section. And this is just running a very easy checkout operation. That's pretty much all we wanted to cover there. So we've enabled developer mode. We kind of get an understanding of how this is configured, and the replica name has been added to the build name within that folder. So now we want to kind of take a look at how we can improve or optimize business continuity with horizontal scaling. And that's, again, where the shared storage will persist the data within the Jenkins home directory so that you're not losing anything, right? If you have a problem interacting with, with your recovery point objective or your recovery time, during certain disasters, then this will be crucial for you, right? So we'll create a new folder. We'll verify that that actually appears on the other replica, and that happens lightning fast. Then we'll just switch back to the other replica, create a new pipeline within that folder, and kind of verify the same thing. Is everything synchronizing from one replica to the next? And that's what we want to do within this lab. So in controller 2, we already know it's running in developer mode. At the root level, we want to create a folder called task 3 folder, right? And then we'll verify if that actually runs on the or exists on the other replica once we create that. So we'll go to the root level again. We'll create that folder. And here's something you'll notice. So this is a little bit of a sidebar, but I can create anything I want at the root level here. Any type of item that exists within CloudBees CI, I can create. So we know what we want. That's a brand new folder. And then within the folder's configuration, most people just click save. There's nothing to do. And you'd be right. If this was open source, there's pretty much nothing too special about a folder's configuration. But with our solution, with CloudBees CI, you can actually restrict the type of children items that can be created within that folder. It's not something that's available within open source, at least natively. And that gives you, kind of as the governor of this controller, the ability to get granular with regards to, all right, well, maybe I only want a specific pipeline template to be made available for an application team in this folder, or a certain amount of items. We're not going to do anything here, but something worth mentioning. What we want to do is just create a new pipeline. And actually, you know what? Before we create a pipeline in that new folder, let's verify if that exists on the second replica. So we can click on the link in the footer. So click on on the current replica in the footer, and that'll take us to that high availability configuration. And we'll go ahead and reset our sticky session. Go ahead and reload that page, and let's reset this until we get onto the other replica. Looks like I'm not having much luck with the sticky session reset here. So let me give that another whirl. All right. Give this one more try. Worst comes to worst, I can clear my cookies. And okay, we are now on the second replica. That's exactly what I wanted to do. I wanted to switch over so that we can actually verify if that folder exists, and it does. It was persistent onto this controller almost immediately. So we'll switch back, and if I create a pipeline on this instance, it would get replicated onto the other controller. But we'll stick to the book, and we'll just reset our sticky session. And we're back onto the original replica. So let's create that pipeline. And let's give it a name. So within this task 3 folder, we want to create a pipeline called data synced pipeline. And here's what it's doing. Pretty much nothing, right? It's just using ephemeral agent with the Kubernetes shared cloud that we have labeled Linux, and one simple stage called data sync, and it has a couple of echo commands that we're going to run to literally showcase the data synchronization between controller replicas. So we'll call this data sync pipeline here. And we will be going against best practice as far as not storing this in Git. So you can just ignore that for now. We'll scroll down to the bottom, and the pipeline definition is just going to be pasted here within the script block. Again, that's something that you can grab from the content. So we'll go down here and copy and paste this code snippet right here into the script block. So we'll save it. We'll trigger this pipeline. And we know, all right, it's the replica name has been added to the build output. Now, if I go back to our high availability configuration through the developer mode, we'll reset our sticky session. And voila, navigate back to controller, the root level of controller 2. We'll see that data sync pipeline, and it's even given us the success icon because apparently it has passed. So again, there's nothing really that pipeline's doing, but we know it's been synced over using the Hazelcast library. And we'll dive into actually a little bit more of a complex pipeline in one of our upcoming labs, where we'll kind of talk about, well, what if this replica goes down during one of those stages? Again, thanks to the horizontal scaling, that wouldn't be an issue. That would not disrupt the current run of that pipeline, it would then just be distributed into a different replica, and it would continue to run. An active passive, that is, you're going to experience downtime. So if there's, a very major thing to emphasize with high availability and horizontal scaling in CloudBees CI, it's that you can effectively eliminate your downtime. And that's something people brag about. All right, so we've got a new folder, we've got a new pipeline that's synchronizing into our other replica quite nicely. Now, we want to delete that folder. We don't need it anymore, so that's a very simple operation. And then we'll actually, we can verify if that itself is deleted on the other replica. So there it goes. We'll switch back to the original. I actually deleted it on the second, but it shouldn't matter. So we can go to the HA configuration. We'll reset the sticky session. And that folder's gone. So we're kind of getting an understanding here of what the requirements are. Sticky sessions are required on the load balancer, right? So job definitions, as we have just reviewed, are synchronized across replicas immediately. And the UI navigation between the Operations Center and a controller is available from any given replica. So what we want to do next is create another pipeline, and then we're actually going to configure that to be executed every single minute. So we're going to be creating kind of a cron job here. Why? Well, we want to actually verify that those builds are being randomly distributed by the load balancer across our replicas, giving us a very good amount of fault tolerance. And then we'll change that pipeline configuration to avoid executions every minute, because that's probably not something we want to leave hanging around. So on that same controller, we'll want to navigate to the root level, and we'll create a pipeline called HAHS Lab 3 cron job. So that's going to be at the root level here. I'll paste the name, and that's just going to be a standalone pipeline, not doing anything fancy with organization folders or multi-branch projects as of yet. And then we'll go copy that code snippet. So it's going to be using that same Kubernetes agent. And then we have that cron stage, or rather, well, we do have a cron stage. That's really just doing an echo command. But we also have a trigger. And again, that's going to force this pipeline to run every minute on the minute. So we'll save this. And I want, as we run this, we'll keep an eye out on the build history. We know we're on our original replica. What we should notice is that these builds are being randomly distributed. And if you picked up on how the replica name was, attached to the actual build itself, you should be able to kind of infer what's about to happen here when we kick off this pipeline. And we can do that, if you're following along in the labs here, by just kind of waiting for several executions to run. So I'll go ahead and kick this off, and we'll see the first output, which is running on this replica. In another couple of minutes, or another minute on the dot, we'll see another execution, and they should be randomly distributed. I'll kind of lean on some of my CloudBees and colleagues in terms of how we're looking in the chat. I know I've been doing a lot of talking, just want to make sure that everyone is following along okay. All right. All right, so now we're seeing multiple executions kick off. And in the stage view, which is a much better visualization for this, we can see which replica these builds were running on, right? So we can go to the next build. Or actually, you know what? Let's go back here. So click on the first build, and we'll actually see that it's managed by the current replica that we're on right now. If we went to the next build, we'll see it was distributed to the other replica. It's exactly what we want to see, right? So if you have a lot of parallel executions, again, and concurrency happens within your cluster, which it does in a real world scenario, you're going to have multiple builds a day, multiple releases a day. You know, a lot of that could be flowing through CloudBees CI. So this type of scaling can really help you cut costs in the cloud, increase the performance of a specific instance that may not have been, as performant without this type of capability. So this is going to continue to run, and for the purposes of this lab, I think that's really what we wanted to show, is just how these builds were being randomly distributed. So we'll just go back into the configuration of this, and we will disable the current project so it does not run every minute on the minute. And I want to say that takes us to the end of that lab. Again, we haven't done anything mind-boggling here. Exactly, far from. I think we're kind of covering our bases with respect to some very simple examples. The final lab here, at least for some of the introductory HAHS stuff, focuses on an automatic failover and automatic build adoption. So in that scenario, controller 2 going down, well, I need my pipelines to still run. And in open source, again, with that active passive architecture, that was not a reality. You had to accept downtime, and you had to accept that that would impact your software delivery throughput. If I'm downloading the internet for my Maven application, and that controller goes down, well, in active passive architecture, that pipeline's going to have to restart. With active-active, that's not necessarily the case, as we'll see. So we'll create a new pipeline. We're going to gain access to the Kubernetes dashboard, which is actually something I'll pull up right now. I'm sorry. Never mind. I do have that up. I was just in the wrong browser. So here's the Kubernetes dashboard we can actually sign into with a token that we'll see here within the lab. We'll actually delete the replica, right? We'll delete the pod that's running the current build, and then we'll verify that build is being adopted by the other replica. And this is all still on controller 2. So we know it's running in developer mode. Nothing has changed there. So we don't really need to verify that. But we do want to create a new pipeline called long running job. So we'll do that at the root level of controller 2. And that's going to be called long running job. Another pipeline. So we're just going to be experimenting with standalone pipelines today. And again, we're just going to be taking advantage of the script block here, ideally, and we'll see this within the next lab, actually, the usage of a lightweight checkout, where the Jenkins file will be stored in somewhere like GitHub or Bitbucket, whatever your SCM solution might be. But for demonstration purposes, we'll just take that code snippet for the long running job. We'll paste that within the job configuration. One stage has a shell command. It's pretty much just going to, tell this job to, kind of sleep for 10 seconds. It's going to make sure that it runs in the background as we delete this pod. So I'll save it. Nothing else we need to do there. We're running on the original replica. And let's see if we actually want to build that. Don't want to get ahead of myself here. Okay, no. So we don't yet want to run the pipeline. Once we create that, we'll just leave it. Now we want to access the Kubernetes dashboard. So there should be a file called token.txt within our VM dashboard. So I'll go ahead and you can actually access that through the file explorer, which is what I'll do. And we see token.txt. So if we open that up, we'll see the token that we need to actually log into the Kubernetes dashboard. And there we go. Didn't want to copy the whole thing. And we'll copy that token. Let's navigate to the Kubernetes dashboard that we have. We'll sign in using a token. We'll paste it. And we're in. So, you know why we're not seeing anything? If you're familiar with Kubernetes, we are in the default namespace. So this controller is actually running within the CloudBees core namespace. So we can get an idea of what the CPU usage is looking like. And then we have all of our controller replicas as well as Operations Center that are running. Take a look at other things if you're curious and kind of want to play around a little bit. But let's go back to the instructions and see what we want to do here. All right, so we've selected the right namespace that we want. Now we actually want to run the pipeline. So we're logged into the dashboard. Before we delete the pod that's running this pipeline, let's get an understanding of which replica it's actually running on. That'll be important. So we'll go back to that pipeline that we just created, and it's running on the replica with that NMX8H suffix. So keep that in mind, and then we'll actually run the pipeline. Once we do so, we'll hit up the console output, and we'll see, okay, well, this is managed by the current replica, and that's as expected. Now, we'll navigate back to the Kubernetes dashboard, and we want to delete the pod that's currently running it, which we just reviewed. So we'll go back. Here it is. And actually, you know what? Yeah, go back to that. So here is the pod that's running our pipeline. We want to delete this resource, which we can also do from the command line using kubectl, but again, for demonstration purposes, that's gone. Okay. So we should now see a brand new replica was created, as we can see here seconds ago. Here's the new suffix. And if we go back to CloudBees CI, refresh our page, we see that we're now on the other replica, right? So as that new replica is spinning up, some disaster happened, and the original went down That then kicked this job over to the second replica that we had available, and it's continuing to execute the job with absolutely no disruption. So that is pretty awesome. And if you were to achieve that type of logic in open source, it's going to cost you a lot of time and a lot of compute resources. Because again, active passive is really the only type of setup that you can achieve natively. So I don't think we need to do much else with that job. We verified build adoption. We verified that the new replica has actually been created. So let's verify that in CloudBees CI. If we go back to Operations Center, or actually, you know what? We do want to go back into controller 2. And then in the high availability configuration, we'll confirm that there's the other replica that just spun up. And if we wanted even more confidence, we can see that same pod running in the Kubernetes dashboard. So that worked out, oh, that's the wrong one. That worked out extremely well. And in the event that you have, let's say it's, day 7 into the current sprint, and I just finished kind of testing a new feature for my new, cool fantasy football mobile application, push my latest change to a PR branch, all comments have been incorporated, and the CI build is triggered automatically based on a commit in GitHub. As it's running all of its checks, I go grab a cup of coffee. I'm feeling ready. I'll let the code reviewers know that we'll need their approval and are ready to merge to main. Next stop, happy hour, and then the controller goes down, right? So you have so much confidence in this architecture, knowing that the resources are being automatically scaled up for you. And there's no disruption to your existing running workloads. Absolutely crucial. So we'll kind of come back to that. As a result of a build failure, you've pretty much only had one place to go and diagnose those problems, and that's the console output. So we'll dive into that after the next lab. But what we want to go into next is Workspace caching. So we've set up high availability. We're horizontally distributing our pipelines. This is working out pretty well. And obviously, this is an extremely small scale type of environment we're working with. You can imagine how powerful this could be in your environment. We want to go back to Operations Center. We'll go over to controller 1. And that's where we'll be spending the rest of our time. Really don't have to pay attention to most of these jobs. It's a little bit cluttered as of right now, and I apologize for that. We're going to be operating out of the Workspace caching jobs folder on this controller. So keep that folder open. I'm also going to suggest that you keep the root level of this controller opened up as well. So we now want to be on controller 1. So before we dig into that, we've covered a lot from a high availability perspective, and we will continue to. But I also want to ensure that Workspace caching kind of makes its way into the picture. This is something, if you experience a lot of trouble with build queues, you have a lot of jobs that are kind of waiting on the queue, resource utilization with respect to certain pipelines. This could be a great solution for you to take a look at. So why did CloudBees kind of look into this? Well, with container-based agents, they operate most of the time from an empty volume. It requires most of your builds, most of your pipelines to download dependencies every time it runs, or it recompiles certain code that hasn't changed, right? So there are various sort of ad hoc ways to do caching, but none have been implemented natively. None offered out-of-the-box functionality for artifact managers, which is exactly what we're offering through Workspace caching in AWS S3. So this type of cache could provide you as a developer, flexibility of relying on data from the main branch or from a previous build of the same branch, which can reduce a lot of bottlenecks. So you get faster builds by reusing those cached artifacts, faster feedback for your developers on a specific PR, minimizing queue times for other pipelines that need to run on the controller, right? And in the end, you're avoiding potential release delays. You're saving a lot of time. So again, this impacts mostly developers sort of waiting for builds. We know that is a common problem, and it's something we wanted to address to increase the efficiency for your team, saving a significant portion of your build time. So we'll kind of address that here within this lab by taking a look at the Workspace caching configuration. So there's a plugin that can provide certain steps to download and upload caches to an external storage provider. In this case, it's going to be Amazon S3. And this is a little bit of an example of what the configuration looks like, as opposed to showing you in slideware. We can go navigate back into our lab. And the first thing we want to do is verify that these 3 plugins have been installed. So the CloudBees Cache Step plugin, the Artifact Manager for S3, and then an area where we can actually configure this. That's just going to be an AWS global configuration. So we'll verify that that's been actually successfully set up. We'll validate that. And then we'll actually take a look at a sample Maven CI pipeline that does not yet take advantage of Workspace caching, and one that does. In the end, we'll want to identify, keep a keen eye on the total build duration between the two, see if we spot any differences. I would imagine that we do. So let's step into it, right? The first plugin that I had mentioned, it provides a write cache and a read cache step to actually use separate storage, to use an external storage provider as caches for your workspaces for a given pipeline. The S3 cache plugin, which is what we'll be taking advantage of, provides a specific implementation that are based on S3 buckets. Now, word to the wise, if you are planning to use S3 buckets for this purpose, you will incur additional costs from AWS. We don't work for AWS, so I didn't have to say that, but we are a partner, so I wanted to say that. Just be aware of that, right? What we'll do on controller 1 is actually verify that Workspace caching has been set up, right? And in high availability mode, I know that this configuration is synced with our other replica. We'll do that by going into the Manage Jenkins console, and under, actually, we'll go into the system configuration. And then we'll do a control find on the Workspace caching implementation. And there it is. All right, so we know it's already been set up. We're using an S3 cache. And as of today, I do believe that's the sole option as far as configuring an artifact manager. I know for a fact we are working on other solutions like Artifactory, but I won't speak to that today. So we know that we're using an S3 bucket for the cache. The advanced configuration, right? So kind of getting back to the lab content, we'll cover that here. Let me navigate back to that really quickly. All right, so the job include pattern, right? So if we wanted to, we'll go back. We can set that at the global level for this controller, right? So we can configure specific jobs that are able to use this cache using, a comma-separated ant style pattern if we wanted to. And those examples are shown here within the lab instructions. We're not going to touch that. So we're going to leave this field empty, which means that all jobs are included by default. And then, on the other hand of that, the workspace caching feature is enabled for all jobs on this instance, since we're not necessarily excluding anything. Then we want to configure the artifact manager for S3. So if we took a look at that, we should see, all right, well, for cloud artifact storage, well, we want to take advantage of an S3 bucket to do that. So we've set up everything we needed to for the system configuration. And on the AWS side, well, whatever role or user I might be using from an identity and access management standpoint, I need a policy attached to that with permissions associated with, putting objects into a specific bucket, pulling objects, deleting, listing certain objects, and buckets. So you'll want to create in AWS, which we've already done, right? An IAM policy that looks something like this. So we're allowed to list the bucket for this particular resource, and then we're also allowed to perform a certain amount of S3 and KMS related operations thanks to these permissions. So that allows us to actually interact with the bucket related to the IAM user that we'll actually be using to connect. So next comes the AWS configuration. Now we actually want to validate the name of the bucket, corresponding credentials, and then we can confirm whether or not we're successful in connecting to that. From there, we'll take a look at the pipeline and we'll run it, right? So back in CloudBees CI, we'll go to our AWS configuration. That's under System. There's the bucket name that we just reviewed in the instructions. You can choose, specific base prefix if you wanted to store these artifacts a specific way within the bucket. Custom endpoint, right? But we're not doing anything fancy here. Really, all we need is the bucket name, the region, and then the access key and secret key ID that we've included as AWS credential within the global system scope. So what we can do is validate this, and we should see a success. So we go back, and we should see what the screenshot gives us in the lab instructions. And we do. So we see that success message. That means we're ready to go. Workspace caching for this bucket has been successfully set up. And we'll go ahead, we'll navigate back to that workspace caching jobs folder. And then let's navigate into this workspace caching demo pipeline And again, it's just a Maven continuous integration build. So we've been properly set up in AWS and on CloudBees CI. Everything is configured. Now we actually want to run a Maven pipeline. And at the root level, you'll see we're abiding by best practices here. We're using agent none. We're giving this actually a timeout parameter, which we shouldn't hit. And then just a simple build stage. Again, you might have multiple stages after that to run certain tests, to deploy infrastructure. Right now, we're just focusing on the build aspect of this to show you the gains of using an external cache. So we don't actually have those pipeline steps implemented yet. This is how you would, run the pipeline without Workspace caching. So it's going to check out the source code from the Kubernetes plugin repository. It'll build the Maven project with a Kubernetes agent that we've labeled Maven, run the Maven package, skip some certain tests, and then we'll see the output of that build. And by the way, on this controller, we go in and manage Jenkins and we take a look. We have the ability to specify certain pod templates that can be launched as agents within this cluster. So again, a very cool aspect of being able to host this on Kubernetes. We can take a look. All right, well, we know that we have a Kubernetes pod labeled Maven. We're only going to use this when pipelines actually have the matching label expression. And then a container template. We can add multiple container templates per pod. So that's one of the major differences between Docker and Kubernetes, and the whole concept of utilizing a pod as kind of the basic unit of computation. Now, we'll use this Docker image, and then there's really nothing else to cover here. So here's that empty directory volume. And we don't want to retain the pod, right? Because that will terminate at the end of this pipeline. It's ephemeral. It's exactly what we want in order for us to cut compute costs in the cloud or elsewhere if you're running this on-premise. So that's something I wanted to make everyone aware of before we actually run the pipeline. So we know that Maven agent is running as a Kubernetes agent, and we can actually specify the container to use. If we had a node or a Python container within that pod template, we could specify those for various stages within our pipeline, giving you a ton of flexibility with knowing where your tasks are being executed, which gives you a lot of freedom. All right, so let's take this. We'll copy it. And you know what? We might not actually need to, because I believe if we take a look at the configuration of this pipeline, it should already be configured. So we just have a discard policy, and we're gonna fetch this from Git. It's a public repo. We don't need any credentials, and there's the name of the pipeline. It's just a simple Jenkins file. What we'll want to keep an eye on when this runs, now that we know what we need to actually interact with that S3 bucket, these two steps are mandatory. So here's the previous pipeline, and here's the new pipeline with our read cache step and our write cache step. Right, and we're doing that with, obviously the read cache should come before the build, so that if you have written anything previously, it will pull those exact same artifacts in for this new run, which we will see in real time. So it'll retrieve the specified cache from storage, and it's going to restore all of those files into the current workspace, right? So if you had certain, well, I was going to say the job include pattern doesn't necessarily fit here. Now it's worth mentioning that the cache context is important here. So if we are specific to this pipeline, this cache will have its own folder within S3. Another pipeline referencing, Maven cache will have its own, sort of directory. So it's the cache here is very specific to this pipeline. And then the other step is, all right, well, since it's our first time writing to this new cache, well, I want to give it a name. We'll give a comma separated list that decides the set of files to actually include within the cache. And then similarly, if we want to exclude certain files, we can do that as well. So once we build this, we'll actually see that it will check the cache. And since we haven't written anything, well, there might not be much to do there. So let's run this. And we'll actually navigate to the console output. The Pipeline Explorer is coming up. You can see it's managed by one of the replicas that we have configured. And for this controller, I believe we have 3 replicas defined. There's that timeout policy that we just saw. And there's that Maven agent. So this is, another unique benefit of being able to define, dynamic agents with Kubernetes is the ability to have the entire definition output within the log. So we can get an understanding of the pod and the container spec as it relates to this current pipeline run. So let's scroll to the current point. And it just got done checking the cache context for this pipeline. And if you noticed, we'll go back up. It's telling us that the Maven cache doesn't exist for this pipeline, for this specific context. So for now, there's nothing to pull in. We're going to have to go and download from Maven Central, right? So as it does this, we know which replica it's actually running on, which again is surfaced here. And next time we do, we execute this pipeline, we should actually be able to read from that Maven cache. And I've got the S3 bucket pulled up here. Here's the bucket. Doesn't look like we have anything uploaded yet, but we'll check back as a result of this. My goodness. Execution. And, as expected, this is going to take some time. Without any proper artifact management here, we're having to download everything from the internet, perform the build, and then upload those compressed files to the specified cache. And when this does complete, let's keep an eye on the total time it took to build this Maven package. And here we go. So just over 2 minutes. If we had a longer pipeline with much more to do, then this could take maybe 15 minutes, maybe 20 minutes. Now we're actually preparing to upload that compressed set of files that we specified within the pipeline. So let's go ahead and take a look at that again. All right, well, we're going to include everything within that M2 directory. We're not specifying any files to exclude here, so that's all we're doing. And then we'll slide back into S3 to confirm that that cache has been uploaded. And we'll run this job again, and it should go much, much faster. So imagine, this happens in active passive. I don't have anything to fail over onto, or rather I have to wait, because as that other environment spins up in active passive, which could take minutes, could take an hour, my pipeline is suffering the consequences of that. With this architecture, that's not the case at all. All right, so we've successfully uploaded the cache. And let's go ahead and verify that within S3. Voila, there it is. So we can navigate into this cache. If I ran a different pipeline that utilized that same name, it's going to create a different folder within this bucket specific to that cache context, specific to that pipeline. So here we are. And we have one object, everything we need for our next pipeline to be able to increase our throughput. So let's run that again, now that we know we've officially taken advantage of the cache. We'll go ahead and navigate back to the console output. We won't have to wait on the Maven agent. That should be waiting around for us. Checking our cache context, it found the cache. Now it's downloading all the files we need to carry on with this Maven build. 15 seconds, all it took. And this build should complete in well under a minute. There it is. So in just the Maven build, right, we have minimized that from 2 minutes and 11 seconds to 20 seconds. You think about how many jobs you have running concurrently on your controllers in production. If you do struggle with build queue times, this could be a lifesaver from an artifact management standpoint and can significantly help you meet your KPIs associated with delivering new features and keeping things going at a rapid pace. So it's going to upload that new archive for our cache, and that'll be that. Very, very simple example of workspace caching. Everything that we just stepped through, it was pretty much documented to the T in that lab. And so now what if something went wrong during a specific pipeline stage? What if and it's not a what if, you do need to easily be able to comb through your build log. All doors led to the console output in the past, and they still do for certain teams, especially for those who are not on CloudBees CI. So if we go back to our slide deck here for the last time, or maybe not the last time, but one of the last times, we'll take a look at Pipeline Explorer. Okay, so this was a revolutionary feature that we had added, and the performance of a build log should be lightning fast, which we all know is not the case with the console output. It had trouble loading, hundreds of megabytes, for example. You should feel like you have access to do whatever you want within the logs and the right, visual aids to be able to troubleshoot easier, which are all things that are absent from the console output. So with the CloudBees Pipeline Explorer, you have a much more performant log viewer. you have very focused troubleshooting. And it really is designed to kind of handle debugging at scale, where you can easily notify certain team members of a specific line within a log, or you can download the entire, you have a lot of flexibility here, including syntax highlighting. All of those things we'll kind of drill into. And this is something that is not making its way into open source. So I do also want to make that abundantly clear. The CloudBees CI high availability and horizontal scaling architecture, along with Pipeline Explorer, actually will not be available in open source. So these are, as you can see with the short GIF animation that we have on the slide, kind of a teaser into what the Pipeline Explorer looks like. It should load extremely fast, and we'll see that. And you can customize that. So if you like specific UI for your Pipeline Explorer, there are a lot of options that you can tweak to make it feel like your own. So let's go and take a look and see if it's installed first and foremost. Before we do that, just know, again, it's extremely performant. It can actually handle up to, I want to say, between 1 and 5 gigabytes of build logs. So it's extremely performant. And it has its own search feature that you can actually use to get specific in your drill down operations. And from a visualization perspective, it is much, much better than the console output. And there's more that we're going to be doing with the Pipeline Explorer into this new year on that front, on the visualization front. I know, some of you may be familiar and actually use Blue Ocean today, which is that pipeline visualization add-on. That is pretty much going away, and this is going to take its spot. So keep an eye out for some really cool changes coming to the Pipeline Explorer. But let's take a look at some of the exciting changes that have already made their way. On controller 1, we're going to stay within this Workspace caching jobs folder. And if you don't have this job created, you might not, because I may be using a different template than you. All you need to do is create a pipeline called Maven Pipeline Explorer example. So there's the name. And then we'll scroll to the bottom. And this does exist within this particular repository. So I'll share that within the chat. So this has already been configured. Public, don't need any credentials. And this is actually the name of the pipeline. So we have another Maven CI build that we want to run, but it's going to be visualized a lot cleaner in the Pipeline Explorer view. So if we go back and we take a look, here's the pipeline that we want to run. So what this is going to do, we've got 2 functions that are defined to basically execute a script. And the script prints out information about the branch. That's pretty much it, right? It's not doing anything special. We've got a pipeline block here, an environment block with the max value of 1, just to kind of indicate what an environment variable would look like here. And then our stages. So we have a parallel stage. And then within that parallel block, we have 3 branches that are going to execute at the same time. Branch A, branch B, and branch C are going to execute all together. And then we have our build process. So this has an agent, again, labeled Maven, that we want to use to check out code from a GitHub repo, run some Maven commands, and then that post block will specify some actions to be taken after the stage completes. Including recording some JUnit test results and archiving artifacts. So all in all, what this is going to do is really just a parallel execution of scripted commands within some of the functions that we laid out, simulating what it would look like if multiple branches actually ran in parallel. So the actual functionality of these stages would differ in an actual real world scenario. So let's run this. And when we run this, we'll click the name of the build. But as opposed to going to the console output, now we want to hit up the Pipeline Explorer. And this is going to be a very new experience for those that haven't seen it yet. We're automatically loaded to the bottom of the log file, right? So we don't have to continuously try to keep up with all the different stages. In this tree view, right, we see that all the different stages that we just reviewed, and we can kind of easily filter between what we want to visualize in that view and what we don't. We see the nested stages that we can easily identify as being nested. And then this will just auto refresh, again, based on the settings that we have configured for Pipeline Explorer. The number of lines is quickly adding up, but now we've reached the build stage, and looks like we've ran into an error, which is also an important thing to cover right now, because that's one of the biggest reasons this exists, is to quickly and efficiently understand the error and how I can notify the right people to resolve that. If I wanted to sort of maximize the real estate, right, I can do that by clicking this button here, and it'll maximize the screen into a new tab for me. So I have much more to work with here. We can get a quick idea of the number of lines in this log file, and then I can download this entire log, send it to those who need it right away. We go back here. The filter by tree view is extremely easy to understand, right? Or really just the tree view is what we'll call it. In the past, if I go back to the console output here, I don't get nearly the amount of insight I do with the Pipeline Explorer. This is all very clunky. I don't know what's going on right now. If we go and take a look at the parallel execution, it's all just out of whack, right? So we don't see anything about the nested stages, for branches A, B, and C. But if we go into the Pipeline Explorer again, that's all extremely easy to digest, right? I can, kind of collapse that. So now this is much easier to comprehend. I have my parallel stage, and you know what? I just want to take a look at all of the results within that particular stage. And since it has nested stages within it that are executing in parallel, we'll also see those within the log itself. But you know what? Something odd happened within the nested C22 stage, and I just want to review those results. So I can actually do that by clicking these UI elements in the build log itself. And if I wanted to zoom back out into the parallel stage itself, now we're viewing everything again. Okay. The search bar. So since I know that this is a Maven build, let's go ahead and type in Surefire and press enter. Let's see what we get. All right, well, that's going to print out every single line that has the keyword Surefire in it. So we can kind of sift through this. If there's something more specific, search for it. The results will be returned within seconds. And this is 3,500 lines of code, and that's nothing, So as you scale your pipelines, as they become more complex in nature, this will save you a significant amount of time in troubleshooting. So if I indicate, if I wanted to share this specific debug line from our log with one of my team members, well, I can copy the link to it, and that will show, and I might be having an issue with the clipboard here. I can copy that link specific to a line within the file and share that as needed. Or I can jump to it, right? So within the full log itself, I can click this button. That'll take me to the line within the actual log. And there it is, highlighted here. So I'll exit out of this. We'll go back to the log. So we can click this button to exit out of the search, or we can go back to the search, right? Also important to cover user preferences here. So as we might have run this pipeline, 20 to 30 times, I get an idea of how I like to troubleshoot, how our team prefers to visualize certain aspects of pipeline output. And this is where you would do that, right? So you can click the cog under right above the CloudBees logo, and that'll give you access to your user preferences. We might not need to see line numbers, so we can toggle that off, and now within the build log, we're just seeing timestamps. If I took a look, type in debug, since we know that has some color to it, I believe. Or actually, you know what? Since we're in the search, it's not showing colors. But if I wanted to, let's filter branch A, for example. Trying to find one with colors here. Okay. Regardless, you can turn those on or off, right? And they are going to be based on ANSI. So we'll turn those back on because those are visual cues that we might need to easily pinpoint an error. Word wrapping, timestamps. Yeah, we want to leave those on, right? So we can select from, all right, absolute time, maybe elapsed time since the start of this build, as well as additional behavior that you can customize. Well, you know what? Since I like the tree view, I might want to just star that. So every single time, or actually, you know what? That was already starred. So now that just changed my favorite view to nothing. But I do like how my pipeline is visualized here. So maybe I select that as my favorite. And then you can easily access, toggle that on or off. But maybe I want to switch to the Issue Explorer view. So the next time I open up this Pipeline Explorer, I'll be presented with all of the issues or none of them, ideally none of them. A couple of other things to note here. It will scroll to the last line as it loads in the log file. By default, you can toggle that on or off, and then the ability to scroll to the actual cause of the failure on load, which might be an interesting option, especially if you choose to pick the Issue Explorer as your favorite view. So this has been saved. If I closed out my user preferences here and I refresh the screen, or actually, you know what? Let's go back. Go back into the Pipeline Explorer from the build, and we should see, yep. So we defaulted to the Issue Explorer, and right away, we get an idea of what the error is. So we can actually expand that and it looks like, oh, this is easy. There's no such DSL method post found among any of these steps. So what that tells me is if we take a look at our pipeline again, I've probably incorrectly formatted the post section where we want to review our JUnit results as a result of running those tests. That's an easy fix. But again, it's something that I might not have caught as easily with the console output as I would have here, where this is the first thing I'm presented with. And even if it's not, right, if I'm not encountering issues on a regular basis with this, well, great. I don't care about the issue explorer. I can just select the tree view. And you're good to go. So if, again, we kind of take that idea of running with multiple replicas, this helps you out very much. If you are experiencing, the disruption of a specific pipeline while you're troubleshooting, that's going to be extremely hard to kind of pick back up on whenever, again, this is kind of active passive. When that new infrastructure comes up for your secondary instance, you're going to have to start troubleshooting all over again. You were in the zone, right? Up until that controller went down, which caused issues to your pipeline and ultimately your browsing experience. You can no longer access Pipeline Explorer. So these all intersect with one another. Throughout the labs today, we've kind of gone through really a basic understanding of how to set up high availability and horizontal scaling with Kubernetes. Again, which is much easier, much more simple to do than it would be in traditional architecture. You can still achieve active clustering with VMs on premise, but it's going to be much more overhead. So again, if we go back to controller 2, for example, take a look at the configuration of it. All you need to do to set up high availability, so we'll navigate back to there right now. We'll hit up the configuration. As you're creating your controller, this is the only thing you need to do. So you need to literally select that, yes, we want to run this managed controller in high availability mode. This is the default number of replicas. Here's the maximum number. Here's our CPU threshold. And this is the last thing you need. We need a storage class that has read, write, many access to our file system, right? And it needs to be NFS compatible so that we can ultimately share data across from the Jenkins home directory specific to that volume. Save this, and your controller is up and running in minutes, already in high availability mode, and you're ready to rock. Now, like I had mentioned, we didn't really go through things like configuration as code today, which can take these concepts to a different level. If you'd like to govern a lot of these changes, restrict certain operations in the UI, you can get really, really cool things accomplished with configuration as code. And there are a lot of enterprise capabilities that CloudBees CI has that open source Jenkins just does not. So I'll go back to Operations Center, and that's pretty much what we wanted to achieve today. I know that this was very different from how we've run workshops in the past using Heropa. So would definitely love to collect some feedback there. And the environments will be up until the end of the day. So I believe they'll be running for about 3 to 4 hours after the class ends. And you'll be able to log in using the exact same credentials, which we shared in the chat. And you can also find them here. So it's going to be system admin for the username and system admin for password. So if you weren't following along today, things kind of broke apart. Just know that this will be available for you to do at a self-paced manner for the remainder of the day. But I want to say thank you to Bill for answering some questions I see that were posted in the chat. Thank you, Erica, for kind of coming on and supporting as well. But I'll be hanging around for the next 10 minutes or so. I know we've got a little bit of time left over. So really appreciate everyone's investment in learning more about high availability, horizontal scaling. This is the tip of the iceberg, as it relates to some of the other concepts that we discussed today as well. So, we're going to iterate on this and bring some fresh new content to you all next time. I will keep my eyes on the Q&A panel. But other than that, you're free to drop, everyone. If you don't have questions, again, I really appreciate your time. And Nadia, if I didn't answer your question, the issue explorer, which is one of the last things that we reviewed, is exactly where you would look if an error occurred within your pipeline. All right, well, it doesn't look like we have any questions coming in. I was playing mannequin there for a second just to see if I would force anyone to ask questions. But thanks to Techstrong, and it looks like we're ready to wrap up here. Have a great day, everyone.
Awesome. Well, Ian, thank you so much for joining us today and walking us through this hour and 50-minute workshop. I know we had about 10 minutes to spare, so you made it through with time. But yeah, no, thanks again for all the work that goes into putting the workshops together, making sure the systems are in place and making sure that things work the way they need to. And I also want to thank you for making yourself available for any follow-up questions to our audience if anyone does have those questions.
You got it. It's our pleasure.
Awesome. I'd also like to thank Erica and Bill for stepping in and answering some of those questions in the chat. Really appreciate that support on the back end. So to everyone who is still here, thank you for attending this workshop. I know we took 2 hours of your time today, and we appreciate you spending it here with us at Techstrong Learning. I'd like to thank CloudBees for bringing this program to you today, and to our audience once more, thank you so much for your time. We appreciate you spending it here with us at Techstrong, and we hope to see you at a future learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, guys.